Hey guys, I'm so excited this morning to come and talk to you guys about the law of sines. So basically, this video is going to be an overview of some ideas for law of sines, how we did that, how did we come up with it. So for example, we're going to talk about area. We're going to talk about how do we get the law of sines from area of a triangle. And we're going to talk about when to use the law of sines. Now, this is not a example video. I'm not going to really go through too many examples. This is more of an overview of the ideas video. So if you want to skip this video and just start working on just the examples, you definitely can do that. But I'm really excited about this one because I love proofs and all that stuff. So let's get started. So the first thing is we had basically we had this problem. Okay. We have the problem that if I've got triangle A, B, C, and this triangle A, B, C, I know if I wanted to find the area of this triangle, given the height, and let's say this is the base, okay, and oh, by the way, let me mention that the lengths across from A, B, and C are known as, for example, across from angle A would be little a, the side of A, across from angle C is little c, and across from angle B would be little b. All right. So that said, I know that to find the area formula of my triangle is 1/2 of the base times the height. Problem is, what if instead of giving you base and height, I gave you the base, I gave you C, I gave you C, and I gave you the angle of A. All right? I gave you the base, I gave you C, and I gave you the angle for A. All right? So, the thing that would be missing there, in this case, would be the height. Now, you could solve for height and do all that stuff, but there's something a little bit more intuitive. And that's what we're going to talk about. So the first thing that I'm going to do is I'm going to say, hey, looking at, if I'm given this angle right here, I can see that inside of my triangle, using the height, I've got a little right triangle, don't I? Right? Because this is a perpendicular distance, right? So that said, what is sine of A? Well, remember, we know from SOHCAHTOA that sine of A just has to be my opposite side over my hypotenuse. So sine of A is just going to be H over C. Now let's take this a step further. And let's say, hey, all right, well, what if I just want H by itself? What if I want just the height by itself? Well, that would be H equals C sine of A. Okay. All right, well, if the height is just C times sine of A, if the height is just C times sine of A, check this out. Can't I just take this and stick it in there? So therefore, we've got 1/2 B C and this is area using sine. 1/2 BC sine of A. And funny enough, this works with all of the angles. And I'll explain what I mean by that. So notice B and C, these are the two rays or two line segments that make up this angle A. So in other words, we've got side B, side C, and then angle A. All right, we got side B, side C, then angle A. Let me just go ahead and erase this. Another example is if we had, so once again, A, B, C, and we could have maybe C, B, so the area of this triangle, for example, would be 1/2 C, AC sine, sorry. Okay. So the idea is whenever we're using these, we're talking about, and then whenever we use the law of sines for the most part, we're going to be talking about, for area, the two sides that make up that angle. So it would be CA sine of B and so forth. All right, that was simple enough. So we can say, and we can prove all of these with the same logic, but just go with me on this. 1/2 AB sine of C equals 1/2 BC sine of A equals 1/2 AC sine of B. Okay. Why? Because these are all the area formulas. Remember, these are the two sides that make up this angle, two sides that make up this angle, two sides that make up this angle, and so forth. All right. We know all these are true because of the area formula we just found out. Now, what if I decided to multiply everything by 2? What if I decided to multiply everything by 2? What would that do? That would give me just AB sine of C equals BC sine of A equals AC sine of B. Check this out. What is going? The 1/2. Now, what if, let's take this a step further. What if I decided I don't like AB, BC, I don't want all that stuff on the front? Well, how can I get rid of it? Well, let's divide everything by A, B, C. What? We then now have, check this out. AB cancels with AB, BC cancels with BC, AC cancels with A and C, and you're left with sine C over C equals sine A over A. Sine B over B. What? No. And this is the law of sines. The law of sines is a ratio. It's a proportion. It tells us this to that and kind of thing. So this is where it comes from. It comes from just all of those area formulas. Now I'm going to get into at least one problem real quick. I'm going to get to one problem really quick here. Give me 1 second. All right. Let's say just for kicks, we've got, now I'm going to make it easy, so I'm going to actually make this a right triangle, but obviously this is mainly used for non-right triangles. But say this is 30 degrees. Actually, the way I've drawn it, this should be 30 degrees. All right, let's say this is 30 degrees, okay? Let's say this is 90 degrees, even though, like I said, this can be used on non-right triangles, but I'm just using it for a right triangle just so that things will come out really nice for us. All right, that said, let's say that we know that this side is 6. Okay. And actually, I'll tell you what. Instead of looking at the 30 degree side, let's look at the 60 degree side. Say we know this side is 6. This side is 3. What's the area? Well, to find the area, we're going to use the formula 1/2 AB sine of C, or just 1/2 these two multiplied together times sine of 60 degrees. Now, sine of 60 degrees, let's see. I mean, we could actually put it in our calculator, but we got the unit circle. If we look at 60 degrees, which is right here, and we look at the y value of 60 degrees, it's 3 over 2. So we can see that sine of 60 degrees is going to be 1/2 root 3 over 2. Or rather, it's going to be root 3 over 2. So therefore, the area is going to be which if you multiply it out, let's see, this is going to be 18 root 3 over 4, which gives us 9 root 3 over 2, which basically yields us like 4.5 root 3 or something like that. But this would be the area. All right. That's done. So that's our area. Now, what if instead so that's how to use area. What if instead, same thing, well, let's say we did not know that this is a 90 degree angle, just for fun. And let's get rid of that. Let's say I wanted to figure out, let's call this side B, side A. Call this A, B, C. What if I wanted to figure out angle A, little b, and little a? I want to figure out angle A, I want to figure out little b and little a. How can I do that? Well, what you're going to do is you're going to say, okay, angle A has to be 180 minus the other two angles, which happens to be 90. So we know this now has to be 90 degrees. Once again, will it always be 90? No. Just using that for this example. Then we want to find little a, we want to find little b. Well, now we can use the law of sines. Law of sines states that sine, excuse me, b over b, for example, let's say we're trying to find little b, would equal sine c over c. Why do I want to pick sine c over c? Well, because I already know what sine c and c are. I already know what they are. So that way, I can now just take this, obviously, replace it with sine 30 over 3. Now, I already know what angle B is. This gotta be 60. So to find B, all I gotta do is cross multiply, do some algebraic tricks, and fix it. So that said, I'm gonna get rid of the diagram here. Now that you all know how to set it up. So we've got sine 60 over B equals sine C, or 30 rather, over 3, which if you cross multiply gives you 3. Sine 60 equals B sine 30. You keep going, you get B by itself by dividing sine 30 on both sides. Right? And then from that, we get B equals 3 sine of 60 over sine of 30. And that is 2 point three times sine 60 there we go, that makes more sense. 5.19. Yeah, that makes sense. Same thought process can be done for A. All right. Now remember, we already know that angle A, was 90 degrees. Now, we know that little b, 5.19. Last thing we got to find is little a. So to find little a, use the exact same formula. All right, I'm gonna go ahead. Sorry, I got 30 over 33 set up. I'm gonna do 90 over a because I'm trying to find little a. And let's go. So first thing I'm gonna do is multiply out 3 sine 90 equals a sine 30. Divide everything by sine of 30. 3 sine 90 over little a. I'm gonna go ahead and tell you. Well, sine of 30 is 1/2. Sine of 90 is gonna be, let's see, 1. So it's gonna be 3 over half. This is gonna be 6. This is gonna be a. It doesn't look like an a. Okay. And that's how you do it. Now, the last part that we need to talk about is determining whether or not the answer you get makes any sense. In other words, here's the deal. If you've got, actually, let's look at the triangle. If you've got a triangle, notice if I'm looking at this acute angle right here. Notice that this side this side right here has to be longer than the height. Has to be. Okay? So the idea here is this. If you're given an angle, and you are given a side length. Okay, that's across from this angle. Then this better be longer than that. Otherwise, it won't create a triangle. Why did I say that? Well, let's look at it. If I were to use a protractor, you would see pretty quickly that, let's say it was shorter. This length was shorter. Instead, it only came out, say, to here. Well, look, if I were to take this, there's no way this piece right here will ever actually touch the opposite side. So all you have to do is look to see, is the side length opposite my angle longer than my height. And how do we calculate height? Well, don't forget, height's just right, it's just this one, this length. Height is just this length times sine of your angle. Okay, so that way you can calculate what the height is, and you'll be good to go. All right, so that's the end of our kind of general idea video. Looking forward to making more videos just on some specific problems. Y'all have a great day.